Cylindrical coordinates. In order to understand cylindrical coordinates, you need basic knowledge about calculus, and I'm assuming you're familiar with. So let's start. Cylindrical coordinates. In order to understand cylindrical coordinates, we need to fix some parameters. Okay, r is the distance between the origin and the physical point P. Theta is the angle between the vector displacement r and the x-axis. Lambda is the unit vector along the direction of the displacement. Mu is the unit vector perpendicular to lambda. Okay, let's start. What is the vector displacement? Is simply the distance r along lambda. Okay, what is the velocity of t? Is the derivative of the vector displacement. Let's calculate it. So it will be equal to r dot along lambda plus r along lambda dot. But what is lambda dot? We can simply see it from the graph. Lambda is equal to cosine theta along I plus sine theta along j. Then we can do the derivative to see what it is. So let's start. So we have said that lambda is cosine theta along I plus sine theta along j. What is mu? Mu is minus sine theta along I because it's in the negative direction, and plus cosine theta along j. Minus sine theta along I plus cosine theta along j. Let's make those two derivatives. We have to consider the derivative of lambda dot, but we will see that in the acceleration we will need to consider the derivative of mu. So we calculated so we don't do more steps. Okay, so let's start. The derivative of lambda dot is minus theta dot sine theta along I plus theta dot cosine theta along j. And if we take theta dot as a common factor, we get minus sine theta along I plus cosine theta along j. If we look carefully, mu is minus sine theta along I plus cosine theta along j. So we can write lambda dot as theta dot along mu. What is mu dot? We will make the derivative. It will be minus theta dot cosine theta along I plus sine theta along j. If we look carefully, cosine theta along I plus sine theta along j lambda, so we will get minus theta dot along lambda. Okay, so let's go and substitute and see what happens. R dot along lambda plus r. What is lambda dot? We just calculated. It's theta dot along mu. So this is our velocity. This is our final formula for velocity in cylindrical coordinates, and we can call this one. Okay, let's go on. In the same way, we have to do the derivative of the velocity, dv over dt. You have understood the method. You have the tools, that is mu dot. So doing this square lambda plus 2r dot theta dot plus r theta 2 dot along mu. And this is our formula for the acceleration in cylindrical coordinates. And this is usually very used in physics. So we can assume, to summarize that, summarizing. So r is r along the vector this is r, the distance between O and P. Okay, This is x, this is y. So we have that the velocity is equal to the first derivative of r, the vector displacement along lambda, plus the r along lambda dot. And we know that lambda dot, I just left it like this in order to remind you that lambda dot is equal to theta dot along mu, so we will have that it is equal to r dot along lambda plus r theta dot along mu. And this is the final formula for acceleration. If you like this video, subscribe and wait for more videos. Goodbye.